Hello everyone. Today's problem is called count the hidden sequences. So let's see the problem statement. It says that we are given an array of differences. So differences has a size of n, and what it denotes is that let's say we have some original array which is not known to us, so that's why hidden, and there is a number, let's say 10, 15, 16, 12, let's say this much. So here four elements. So second minus first is 5. Here second, third minus second is 1, and then it's minus 4. So this is differences, and this is given to us. And we have to find how many such hidden arrays are possible. So if you see that if you increment all these values by a fixed number, then this again you will get the same differences. For example, let's say you add 5 to everything or 10 to everything. So this will become 20, 25, 26, and 22. Again, 25 minus 25, 26 minus 25, 1, 22 minus 26 minus 4. And that's because if you have a minus b equal to k, then you write a plus x minus b plus x. It will still be a minus b plus x minus x. So it's still k. So there are infinite hidden arrays possible for which this difference array can be created. But to limit that, we are given two extra values, lower and upper. So all the values in this original hidden array, so if you look at individual values, they can take a minimum value of lower and maximum value of upper. So let's say now we are limited that lower is let's say 5 and upper is 20. Now you see that here the lowest was 10, here lowest is 5. So if you decrement everything by 5, you will get that same difference because you are allowed to. So if you decrement everything by 5, the minimum here is 10, which becomes 5, and you can increment up to whatever is the maximum value is 16. So 16 plus 4 is 20. So from 5, if this is 20, then minimum will be 14. So from 5 to 14, you are allowed. So this min. So let's take an example, then it will be, I think, more clear. So let's say this is the differences. Uh, so let's start with 0. So if this size is 3, we know that in original we have 4. So let's say the first value is 0. And in that way, minimum among these and maximum are 0. Let's say initialize. So first is 0, next is 1. So that means this was 1. Then we have minus 3. So that means it was minus 2. And then 4. That means it was 2. Now here the minimum is minus 2 and actual minimum value is 1. So we need to increment it by 3. So this, so that it becomes 1. And this will become 5. This will become 4. This will become 3. And here the maximum is 5. So this is the first value, and the second you increment everything by 1. Then you cannot have any other. If you increment further, you will go beyond upper. So only two possible values are there. 6, 2, 5, 4. These two will give you this differences. So in general, how we can solve that? So you notice that we have lower and upper, and then if you start from 0 and create this, then you will have some lower and upper. So here let's call it min and max. So min is -2 and max is 2, whereas the given lower is 1 and given upper is 6. So here the range is 5, here the range is 4. So 5 minus 4 plus 1 is possibility. If this difference is less, so let's see that this is min, then we have a few more labels, and then we have max. And let's say this difference is D1. So here min and max we are denoting in this array that we created by starting with first element as 0. So here difference is D1. And let's say if we are given that maximum and minimum possible, that is lower and upper, are this much. So here also we have some difference. Let's say D2. So if D2 is more than or equal to, greater than or equal to D1, then only we will have some possibility. If D1 and D2 are equal, then what we will do? So min and max in this is same as the difference between min and max is same as this lower and upper. So we will align this min with lower, then automatically whatever is this max will align with upper. But if this difference is more and the given difference is lower, then if we align this min with lower, this max will overshoot upper, which is not allowed. But if let's say max, if after aligning this min to lower, max comes here, and there are, let's say, three more values possible, including this one. This is 1, this is 2, and 3. So in that case, three values are possible. The minimum is align min with lower, then max will come here. Then align min with lower plus 1, then max will come here. Then lower plus 2, and max will come up to align with upper. Now if you further increase, it will cross upper. So that's why so this difference, outer difference, or upper minus lower, is D2. So D2 minus D1 plus 1. Because if they are same, then we have just one possibility. So the time complexity for this would be O of n, because we just need to build this array. We don't even need to build this array. We just need to keep track of what is the min. So min is 0 and max is also 0. So we only need to store the previous value, and from the difference we can make the next value. So we will see if this value is less than minimum, then update the minimum. If this is more than maximum, we update the maximum. We only need max and min, or the range of numbers in this, the difference of max and min. And so space will be O of 1. Now let's write the code for this. So let's say we have max val equal to 0, min val equal to 0, and val equal to 0, and then so val is the first element or the previous element, and for d in differences, val plus equal to d. So this is the next value in the hidden array. So max val equal to max of max val and min val equal to min of min val and val, and then we will have the difference diff1 equal to max val minus min val, and diff2 is upper minus lower, and if diff2 is less than diff1, then it's not possible, else return diff2 minus diff1 plus 1. So there is integer overflow, so maybe we can keep it long. So let's make it long, and now let's submit again, and the solution is accepted. So I hope you understood this problem. So see you in the next lesson.